Okay, so I'm going to be looking at the unit circle here, and so basically what we're going to think about is, what is the unit circle, how do you use it, and how do you memorize the unit circle. So we're going to start off with what it is. Um, all it is just a circle of radius 1. We have it graphed here on the xy plane, or the xy axis. Uh, the center is 0, 0. We've got different points along here. So this is just basically x squared plus y squared equals 1. That's all it is, the graph of. It's just a circle of radius 1, and the distance all the way around the circumference 2 pi r. The circumference is just going to be 2 pi. So the important thing about the unit circle is it's not important what's inside or outside the circle. The important thing is what's on the circle. So you can see we have different points plotted on the circle here, and all these points, they're all on the circle. That's what we're concerned about. And you can see for these points on the circle, we have the ordered pair labeled here. So we've got the x value for this point and the y, of course, and the y value for that point. We go to this point, so the location of this point is just 0, 1. This is just graphed in Cartesian that everyone knows how to graph with, just on the x and y axes. And we know that since this is a circle, the circle has 360 degrees. So you can see 0 degrees, 90, 180, 270 degrees, 330 degrees, and this goes all the way to 360 here. So, and you can see, where we have these points, they have corresponding angles, right? So 60-degree angle right here. We have 60 degree. I just picked one at random. It makes a 60-degree angle with the horizontal here, and you follow along this angle until you get to this point, and you have a value here at this point, the ordered pair. So the important thing, what is the significance of this? Well, it's for the trig functions. Sine theta. Let's pull this down a little bit. Okay, here we go. If you're asked for the sine of a certain angle or cosine of an angle, tangent of an angle, cosecant, secant, cotangent, whatever, you can figure out the values of these functions by using the unit circle. So, if you want to graph sine of x, if you want to graph cosine of x, you want to graph tangent of x, or maybe they'll just ask you for a certain value on one of those functions, you can figure that out. Let's move this back up. You can figure that out by using this unit circle here. So how do you do that? Well, let's look at the formula here. We have sine of theta equals y, and you can just memorize all 6 of these formulas. They're not hard to memorize at all, So let's first just look at sine of theta. So we have sine of theta equals y. That's the formula. So what does that mean? Well, I'm gonna pick a random point on the circle. Okay, so let's pick this point right here. This point right here. So what angle is it? 60 degrees is the angle, or in radians, that's pi over 3. These are both angles, pi over 3. Pi over 3 is in radians, 60 is in degrees, but they're both the same angle. They're interchangeable. Okay? So let's go back to our formula, sine of theta equals y. You might get asked, what is sine of 60 degrees, right? That's theta is the angle, 60 degrees. Or you might get asked, it could just say, what is sine of pi over 3? And we know that looking at this, it's going to be the y value. So sine of 60 degrees, you would go all the way to where the 60 degrees is. You look at the point here, and sine is the y value. So sine of 60 degrees is square root of 3 over 2. Okay? And let's use a radian now. Let's say, and we'll use cosine this time. Let's say, what if I ask you for cosine of 2 pi over 3? What is that? We're going to start here on your unit circle. You can go over 2 pi over 3. Okay, we found 2 pi over 3. It's this point right here. That's the angle. We found this point right here. And looking at the formula up here, cosine is the x value. So at 2 pi over 3, we're going to look at the x value, negative 1/2. So cosine of 2 pi over 3 is just negative 1/2. Okay, and let's look at tangent now real quick. What if I asked you for tangent of pi over 2? That's just a random one. Okay, we're going to start here again. We're going to go over pi over 2, and tangent is y over x, so 1 over 0. That's actually undefined. Tangent is actually undefined at pi over 2, so if you were to graph tangent of theta, or tangent of x, I guess, when you get to x equals pi over 2, there's actually going to be a vertical asymptote because it's undefined there. That's a point of interest at least. Another thing to point out when you're using the circle, when you ask for a certain value at maybe pi over 2 or 4 pi over 3 or anything at random, you're going to start at 0. That's where you always start, right here on the right side where it says 0. And you're going to go counterclockwise. You're going to go like this. Going counterclockwise is actually not always. Going counterclockwise is going the positive direction. So that's the direction you usually go. So if you ask for sine of pi over 2 or cosine of pi over 2, whatever, pi over 2 is a positive value, right? So you're going to go in the counterclockwise direction to locate it, and you would just find it right there. Now if I ask for sine of negative pi over 2, you're instead going to go clockwise to locate it. So as opposed to traveling here, we're going to travel the same distance, but we're going to go clockwise, and it's going to end up to be right here. So, and you might think, well, this doesn't say negative pi over 2. This is 3 pi over 2, and it actually does turn out that. Hold on, let me move this up. It actually does turn out that this point where it says 3 pi over 2 is actually the same thing as negative pi over 2. It does turn out where if you take any point on the circle, let's just pick this one, if you add 2 pi or if you subtract 2 pi, it doesn't change the value any. So basically, let's show that real quick. So let's say if you have this point here, and let's say we add 2 pi. So what's 5 pi over 6 plus 2 pi? Well, that's 12 pi over 6, 17 pi over 6. That'll come out to 17 pi over 6, I suppose. Just doing quick mental math. So let's travel a distance of 2 pi, and we're right back where we started. Okay, so because the circumference is 2 pi, if you travel a distance of 2 pi, well, sorry, that's only one. If you travel a distance of 2 pi, that's just one full trip around the circle, you're back where you started. On the other hand, if you subtract off 2 pi from any point, going backwards 2 pi, you're still back where you started. So you can always add or subtract 2 pi, and it won't change anything because you'll be back where you started. And so if you get confused, maybe you're asked for sine of negative pi over 2, and you're kind of confused because it's the negative direction. You don't know how far to travel because you can't look at it and see pi over 2. You can just add 2 pi to that. So what's negative pi over 2? If you just add 2 pi, you're gonna get what? Negative pi over 2 plus 4 pi over 2, 3 pi over 2. And so as opposed to just traveling backwards pi over 2, just travel forward 3 pi over 2. So whenever you're asked to locate kind of a negative value like negative pi over 2, you can just add 2 pi and make that a positive. Or maybe you're asked to locate where's 3 pi on the unit circle, and it might not seem that clear looking at this because it's not 3 pi. You don't see it explicitly. Well, we can subtract off 2 pi from something, and that doesn't change it. So if you do 3 pi minus 2 pi, you get pi. And so if we travel pi, well, it's right here. So this is actually the same point as 3 pi because, pi plus 2 pi is 3 pi. Or if you subtract off 2 pi, it's negative pi. So this is actually the same thing as negative pi as well. So it's kind of interesting, sine of pi is the same thing as sine of negative pi, if you didn't catch that there. Okay, so now what I've done here is I've graphed y equals sine of x. You can see that. You can graph sine of x, you can graph here. You can graph sine of x, cosine x, tangent of x, cosecant of x, secant of x, cotangent of x. You can graph them by just making a table, plotting points and making a table. But here I've already graphed sine of x, and you'll notice when you're graphing. Actually, I didn't label this. Let's label this y-axis here. That's the y-axis. That's the x-axis. So you'll notice on the x-axis we have negative pi over 2, pi over 2, pi, 3 pi over 2, 2 pi. They're not like whole numbers. When you're used to graphing whole numbers like 1, 2, 3, 4, 5, whatever, on your x-axis, but here instead of graphing whole numbers, it's actually easier if you graph like pi over 2, pi, 3 pi over 2, 2 pi, because when you're using the unit circle, I'm just graphing these values here. It just makes more sense because I don't know what sine of 1 is, or okay, I know sine of 1, but I wouldn't know like sine of 0.5 off the top of my head, or sine of 0.7 or whatever. It just makes more sense, sine of pi over 2, because using this formula here, it's easy to see, sine of pi over 2 is 1. But that's why we've used these values here. And sine of x, and cosine of x and tangent of x, they're not one-to-one functions. What I mean by that is, a one-to-one function is one x value has a corresponding y value, and it doesn't repeat. But here you see, there's multiple places. There's actually infinitely many. This keeps on going. This just goes infinitely in both directions. But it's not one-to-one. So if you take one y value, let's say y equals 1, there's infinitely many x values for that y coordinate. So, at x equals pi over 2, we have the y value of 1. But also at x equals, this should be negative 3 pi over 2, it's also positive 1. So, that's why it's not a one-to-one function. But another important thing to notice is that the period for sine x and cosine x is 2 pi. So that means basically if you travel a distance of 2 pi, forward or backward anywhere on this function, you'll be back where you started. So let's just start at 0 here, and I'm going to travel a distance of 2 pi. So let's put a dot here. This is where I start at 0, 0. I'm going to travel a distance of 2 pi to the right, okay? So we're going to go, and we're going to end right here. This is where we end. And this graph actually, like I said, it goes infinitely far, whatever. This one goes infinitely far. But you notice, so we travel from here to here as a distance of 2 pi. We're right back where we started. So you can see it loops, it goes up and then it goes down. But these are basically the same y value, 0. And you can see at both places, you're about to go up and then you're about to go down. It's just you can see when you add or subtract 2 pi, we can subtract 2 pi. If we go backwards 2 pi, we're also in the same exact spot. Same exact y value, same spot, basically. But a different x coordinate, obviously. So that's hopefully makes more sense when I said you can add or subtract 2 pi from anything, and that won't change the value. So like, remember when I said, maybe you asked what is sine of negative pi over 2. That's not necessarily obvious, or it might be confusing that it's a negative number, negative pi over 2. And I said you can add 2 pi to negative pi over 2, and that won't change it. It'll make it positive, but it won't change the actual answer. So, to make a negative answer positive makes it easier to solve. So, basically looking at this, it makes sense why you can add or subtract 2 pi and it doesn't change, because we've just showed it here. So that's why that particular trick does indeed work. You can graph, like I said, cosine x, tangent x, by just plotting points, make a table, and you have pi over 2, you have 0, 1, whatever. Just make a table of x and y. You can put x basically like pi over 2, pi over 3, whatever. You can put the y values associated with them, and you'll eventually get a nice looking table. So for example, like if we're doing sine of x, this says theta here, but let's say we're plotting sine of x. You'll make a table with x, and the other one will be y, and y would basically be sine of x. So it would basically be x and sine of x. So x would be, would be pi over 2, pi over 3, pi over 4, whatever, and the sine of that value will just be the y value associated with it. But you'll start to memorize this graph. I didn't make a table when I was graphing this. I've got it memorized. You'll have it memorized. It's not hard to memorize it. It's just a pattern where it goes, up and down infinitely. It's just a matter of plotting a few points and getting the graph to turn out. But you can graph cosine, you can graph tangent. There's a pattern, and that's pretty much. I'm gonna grab another sheet of paper. Okay. So we said, I didn't write this out, but like I said, if you're asked, what is sine of pi over 2, I don't know if that's clear or not. Maybe I should write it. Let's write it bigger. Sine of pi over 2. If you're asked, like I said, sine of pi over 2, well, let's bring up the unit circle. Pi over 2, sine of theta equals y. So, start here, pi over 2. We found pi over 2. Sine is the y value. It equals 1. Okay, let's say... So basically what I've been saying is I'll give you an angle, maybe pi over 2, 3 pi over 4, and I'll ask you what is the sine of that value, what is the cosine of that value. So I might, like what is sine of 3 pi over 4 or whatever. Now what if I asked you, where is sine equal to 1? Yeah, okay. Yes, that's exactly what I want to ask. Sine inverse 1 equals... Okay, so basically I might ask sine inverse 1 of 1, which that will basically be asking where is the sine function equal to 1? So let's look at this. So where is the y value positive 1? There's only one place, and that's right at the top here. You see pi over 2. So you might be tempted to say the answer is pi over 2, box it in and say that's your answer, but that's actually not going to be right. The reason why, it looks like it makes sense at first, you go to pi over 2, the sine of pi over 2 is 1, so it might make sense, but if I ask where is sine equal to 1, that's what I asked, there's actually infinitely many places that is equal to 1. So let's look back at this graph here. On this graph, where does sine equal 1? Well, it equals 1 here, here. But like I said, this graph goes infinitely many times to the left and to the right. So there's infinitely many places where sine is equal to 1, because it's not a one-to-one function. There's infinitely many x values for each y value. So this answer is not quite correct. I mean, at pi over 2, sine is equal to 1, but there's infinitely many places where sine is 1. So where are all the other places? How do we write this? Well, the way you're going to write this, so we have pi over 2 as one of them, right? We can confirm that it's on the unit circle. The y value is 1. But where are the other places? So remember when I said earlier, you can add or subtract 2 pi and that's going to give you the same answer? Well, that's actually going to, what we're going to write is, you can write this is the next, okay. If we do pi over 2 plus 2 pi, it's still going to give you the same y value, right? Remember when I said you can add or subtract 2 pi, it doesn't change the value? So we can add 2 pi, and this is another location where sine is equal to 1. Or, well, what does this actually come out to? This would be what, 5 pi over 2? Yeah, okay. Or maybe I could say 5 pi over 2 plus 2 pi. What would that be? 9 pi over 2? Or you could subtract 2 pi, Let's say pi over 2 minus 2 pi, negative 3 pi over 2. So there's infinitely many, and so what we're going to do is we're going to use a notation because there's infinitely many of them. So we found on our unit circle pi over 2. So let's write down pi over 2. Here's our answer to the question. Where is sine equal to 1? Our answer to that question would be pi over 2 plus or minus 2 n pi. Basically, we want n is, okay, not some, but any integer. N can be any integer. So basically what we've written here, is that clear? Yeah, okay. Pi over 2 plus or minus 2n pi. So basically, you can add or subtract 2 pi, it doesn't change the value, so that's okay. Right, but you can also add 2 pi again, add 2 pi, add 2 pi, or you can keep subtracting 2 pi, you'll get infinitely many solutions. So basically what we mean by writing plus or minus 2n pi is you can add or subtract 2 pi n amount of times. Right, so that covers all the solutions. Okay, so let's look at, let's try to write down here, let's see, let's do cosine inverse 1, 0. So this problem is, where is cosine equal to 0? And you know, there's going to be infinitely many places where this is true. So let's look on the unit circle. Let's bring this up. So where is cosine equal to 0? Well, let's see. We've got cosine is the x value, right? So pi over 2 is where it's equal to 0, and the other part is 3 pi over 2 down here. So, you know, so let's write this. We know that it's 0 at pi over 2. It's also 0 at 3 pi over 2 down here. But, you know, there's infinitely many places. So we could say, okay, so how far apart are pi over 2 and 3 pi over 2? They're a distance of pi apart, right? So if you add, let's say I'm just going to go here. If we add pi, you get here, cosine is still 0. You add pi again, you're back here, cosine is still 0. You add pi, still cosine is still 0. Or let's say you subtract pi, you know, go back pi, it's still 0, go back pi. So the pattern here is there's you just travel pi each time, so you write plus or minus n pi. Now the reason why this one's n pi and this one's 2n pi was because you could travel pi each time and still get 0, whereas for this one, with sine, you have to travel 2 pi. Now the reason for that is, you know, this one we're asking for 0, and for this one we're asking for 1. So the problem we run into when we're asking for 1 is that it has to be positive 1. So see, for sine of this, that's a positive 1, but that's a negative 1, so that doesn't work out. But for 0 down here, there's no such thing as positive or negative 0, so that's why there's double the amount of solutions. Okay? Okay, so we're done with examples for now. Let's look at the unit circle. So the third thing to address in this video is how do you memorize the unit circle? It looks very complex. It has a lot of different numbers, but it's actually quite easy to memorize because there's a pattern. All you have to do is memorize the first quadrant, and you can write out the second, third, and fourth quadrant just by knowing the first quadrant because there's a pattern. So let's look at the unit circle here. So basically what happens is, you know, you travel a distance from here to here. We travel pi over 6, and then here we have pi over 3, which is basically the same thing as 2 pi over 6, but it's more simplified. So let's say let's do this. We're going to travel a distance of pi over 6 each time and see where we land on the unit circle. So let's travel a distance of pi over 6, okay? So we're going to travel pi over 6. We landed on, my hand's in the way, we landed on pi over 6. Let's travel pi over 6 again. Now we've landed here, which is pi over 3. But really, it's just 2 pi over 6, but it's simplified to pi over 3. So this is 2 pi over 6, simplified to pi over 3. Now let's travel another pi over 6. And we're going to get here, which is 3 pi over 6, which simplifies to pi over 2. And then let's travel another pi over 6. Now we're at 4 pi over 6, 5 pi over 6, 6 pi over 6. But you can see each time it's simplified. You know, 7 pi over 6, 8 pi over 6, but it's simplified. 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. Which is also 2 pi, right? So that's that. You know, you can just go pi over 6 each time and just write out those points that I've basically just discussed. But you'll see that they're simplified. So remember, for like 6 pi over 6, just simplify that to pi. And now what we're going to do is, we've pretty much covered every point except for these kind of points in between here, these 4 points. Well, that's basically just traveling pi over 4 each time. So if we travel pi over 4 each time, let's go along this unit circle. Pi over 4, right? Travel another pi over 4, so pi over 4 plus pi over 4, 2 pi over 4, which simplifies to pi half. Now we'll travel another pi over 4 to 3 pi over 4, another pi over 4, so 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So that's how you do that. And you can, you know, you can look at the degrees, and 30 degrees, 45 degrees, 60 degrees, 90, whatever. The way I would memorize these would be, I would write 45 degrees here. I would just write out all the 45 degrees first. 45, 90, 90 plus 45 is 135 degrees. Add another 45, you get 180. Add another 45, you get this. Add another 45, just write out those. And then what you can basically do then is just take this degree value, and for this one just subtract 15, and for this one add 15. So for example, 45, if you go back a little bit and subtract 15, you get this one. And then, but if you added 15 and go up a little bit, you get this one. So you write out those two. Then you're going to go to this one that we've already figured out. Just add 15, or excuse me, subtract 15, write that value, add 15, write that. You can do the same for all those. So now you've basically figured out how to memorize the angles, you know, pi over 6, 30 degrees. So the next thing you want to know how to memorize would be the ordered pairs associated with all of them. So the three different types, actually 4 different values that you can have for x comma y would be 0, 1/2, square root of 2 over 2, square root of 3 over 2, or 1. So let's write that out here real quick. I'm going to write it at the bottom. 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. And these could be positive or negative, plus or minus, right? So in this order, 0, 1/2, square root of 2 over 2, root 3 over 2, 1. That's from smallest to biggest value. So these are values from, you can have x or y be any of these values. As you can see on the unit circle, x takes on those values. So this is from smallest to biggest. So just memorize these 4 numbers, okay? And we'll notice, let's start looking at here, 1 comma 0. Well, you should already know, 1 comma 0, 0 comma 1, negative 1 comma 0, 0 comma negative 1. Those should be pretty obvious. But what's going to be maybe less obvious would be like this coordinate, that coordinate, that coordinate, like what is the ordered pair there. And, like I said, let's look, this one has the largest x value, right? And this one will have the second largest x value. Actually, these two would have the second largest x value. Then a little bit smaller x value, a little bit smaller x value, and then the x value is 0. And if we look here, what we've written down is x value, this is the next biggest x value after 1. So it just makes sense if you shift over a little bit, that this one has the next biggest x value, and if you shift over a little bit more, this one has the next biggest x value, and the next biggest x value, and then the smallest x value. Well, the smallest x value technically is negative 1, but just looking at this with the plus or minus scale. And, you can also see, this has the y value here is 0. Then the smallest y value bigger than 0 would be 1/2. Then you can see as you go from here to here, y value increases, y value increases, y value increases. So it's just going to go 1 up each time. So, just memorizing these 4 numbers, you can pretty much write out all these coordinates just by thinking about it. And, you can write out all the coordinates just by using that kind of thinking. And pretty much once you kind of have this coordinate done, you can just write out all the other coordinates. You don't really have to memorize. You can just look at the numbers down here and kind of think about it, and you'll pretty easily see. And there's a pattern, right? These are kind of symmetrical. The only difference is the x value here is negative, the x value here is positive. Other than that, they're pretty much the same point. Well, they're not really, but you can see the similarities. And that's pretty much how you memorize the unit circle. It doesn't take long to memorize, especially if you understand it's not hard to memorize. You don't have to memorize the whole thing, but you can kind of just understand certain things about it, and you'll be able to draw the rest of the unit circle just by kind of thinking about it and reasoning through. That's pretty much all I wanted. All I have to talk about the unit circle. I hope that made sense. Thank you.